Okay, what I want to do is review what we did yesterday, and then I want to teach you something new today that is related. And this will be our last lecture on lines and angles with regard to geometry. So please pay attention so I don't have to answer extra questions. So let's talk about what we did yesterday. Yesterday we talked about rays, angles, vertices, and sides. Okay? Two rays that share the same endpoint forms what we call an angle. Now remember, a ray has an endpoint and then a line that goes on forever. A vertex is what? It's where the two rays meet and create the angle. And then the sides of the angle are here on the side where the lines are formed. So you need to know the components of an angle. Two rays and a vertice, or a vertex. Now, we measure the size of angles using degrees. We do not use any other measurement but degrees. Now, if you ever study angles in more depth, like in an engineering course, you'll find that you can break this degree up into minutes and seconds, but we're not talking minutes and seconds of time. We're talking minutes and seconds and radians of degrees. So degrees have their own small units as well. But we're not talking about time. We're talking about an actual measurement. We can identify an angle by using a point on the ray and the vertex. The angle below, remember I taught you how to read these. You can read this as angle A, B, C, or angle C, B, A. The vertex is always in the middle when we're reading our angles. So you need to know how to read them. We talked about a protractor as what we need to measure angles. This is why angles are not time. They have nothing to do with time. Angles are actually measured with a protractor. It measures the size of those angles. And we talked about there being two different readings. You have an acute reading and you have an obtuse reading, depending on the size of your angle. You need to classify your angle before you measure it. So I want you guys to show me real quick, what's a right angle look like in the air? Give me some air writing. Right angle. Show me a right angle, everybody. Okay? Obtuse, acute, straight, reflex. So you guys have to remember those angles that I taught you and classify your angle before you measure it. Then you want to see this little hole right here? That's where you stick in the center here the vertex of the angle before you measure it. And we talked about that yesterday. We even measured some angles. Acute angles are angles that are defined as angles that are less than 90 degrees. Obtuse angles are angles that are greater than 90 degrees but less than 180 degrees. Right angles are exactly 90 degrees. A straight angle is exactly 180 degrees and it's a line. So anytime you have a straight line, that is a straight angle. Then we also talked about relationships of angles and lines. So let's review those real quick. Adjacent angles are side by side. And remember, yesterday we said that it's also linear, right? Because you guys had an exercise on being linear or not. So adjacent means side by side. They are sharing a line, okay? They have a common ray in common between the two angles. So that's adjacent or side by side. Here are some examples of adjacent angles. Side by side, got a line in between. 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 Y'all get it? Adjacent angles are side by side with a line in between. These are not adjacent. Where your line at? You got two lines here. What kind of situation is this? What did we call this yesterday? Who remembers? Say that again. You're saying it almost right, Tasha. Vertical.
Vertical,
yeah. Yeah, vertical. She was trying to say it. And then these two angles are not side by side. So these are not examples of adjacent angles because you don't have them side by side with a line in between. Okay? We talked about vertical angles. In vertical angle relationships, the opposites are equal. You have to have a set of crossing lines, and the opposite angles are equal. That is the postulate and rule for vertical angles. Opposites are equal. Now, vertical angles are congruent. That's what you got to remember. Supplementary angles, we talked about this yesterday. Supplementary angles total 180 degrees. But notice, supplementary angles do not have to be adjacent to be supplementary. So I can have supplementary angles that are adjacent, and I can have supplementary angles that are not adjacent. They're still supplementary. They still total 180 degrees. You guys got that? Okay. Complementary angles. Complementary angles total 90 degrees. Here is a set of adjacent complementary angles. That means they're side by side. But they do not have to be adjacent to be complementary to total 90 degrees. So in this rule, they don't have to be adjacent, but they have to total 90 degrees to be complementary. You guys got it? Okay, I'm going to play a little game with you, and make sure this is a little review, and I want to make sure you understand these relationships before I teach you about transversals. So here's the game. You guys don't have to raise your hands. You can just tell me the answer because there's not that many of us. If it was a full class, I would have you guys raise your hand. Now, this is kind of small, I think. So remember yesterday when you guys had to come up here and do the angles? Well, get up out of your seat, pick an angle, and tell me the answers to these angles. I want everybody to do one. So remember, the person who gets up here quicker gets to do the easier one. Okay, so I'm going to pause this while you guys write these up. Didn't we say 63 minus
27?
No, why are you subtracting 9 from 90?
63 minus 25.
Oh, you did 63 minus 25? Okay. 38. Okay. Is that all of them?
Good.
TQS? Did you do TQS? Yeah, you did it. It's 38. Okay, VQR. Okay, Dot, so what's VQR? So 90 minus, what is that? VQ. Well, but you got 90 here, right?
Yeah,
This is a 90 degree, and then go to V. So between the 90 and the V is